Okay, what transformations do you see in this first, in number 3? Very good. Left 1. Oh, wait a minute. Okay, now let's get 3 points. On the assignment that I'm going to give you in a few minutes, I actually give you a chart to fill out. The chart has more than 3 points, but you don't have to do more than 3 points. It only asks for 3. So I'm going to put in -1, 0, and 1. All right, when I put in the -1, again, I'll try to fit it in here. I have -1 plus 1. -1 plus 1 is 0. And what's 2 to the 0 power? Say it louder. 1. It's given. So that's the ordered pair -1, +1. Now when I put in 0, I have 2 to the 0 plus 1, which is 2. And then put in a 1. 2 to the 1 plus 1 is, which is 2 to the 1 plus 1 power, which is, what did you say, Courtney? 4. Oh, I'm sorry, Zoe. All right, let's go ahead and name the domain. What's the domain? It's always, the domain of exponentials is always -infinity to +infinity. What's the asymptote? Remember, the asymptote is always y equals k, y equals 0. Okay, let's graph our order pairs now. -1, 1, 0, 2, 1, 4. And the asymptote is at y equals 0. Then we'll connect these, and it just gets closer and closer to the asymptote. It is decreasing. Wait, is it decreasing? Increasing. Go from left to right. Don't follow the arrows. Go from left to right. What about the x-intercept? None. Y-intercept? Okay, we skipped range, so let's go back to the range. Okay, do you agree it's here up? So it has to be going towards infinity. Infinity always goes on the right in interval notation. What number's on the left? It's going to be your asymptote, 0. Range always has the asymptote in there. Okay, what always goes here?
The positive.
Right. All right, positive infinity means I'm moving to the right. What's the graph doing when I go to the right? It's going to infinity because it's going up. And yes, and as it goes to the left, it goes towards 0. Okay, can you see that it took that regular, your parent function always goes through the point 0, 1. So you see it move to the left 1. Okay, what transformations does this one have? Left 1. Anything else? Is that it? And it reflects. Okay, go ahead and fill in your domain and your asymptote. Oh, goodness. All right, there's your domain. What's the asymptote? All right, put in a -1. So I have -3 to the -1 plus 1 minus 2. Okay, ignore that negative for just a minute. Or first, let's look at the exponent. -1 plus 1 is 0. All right, ignore this negative. 3 to the 0 is 1, and then with the negative, it becomes -1 minus 2. And that's -3. So one order pair is -1, -3. Now we're going to put in a 0. -3 to the 0 plus 1 minus 2. -3 to the first power is -3 minus 2, -5. Now a 1. -3 to the 1 plus 1 minus 2. Okay, so that's going to be -3 to the second power minus 2. That negative is not raised to the power, just the 3. What's 3 to the second power? And the negative attaches to it, so that's -9 minus 2, -11. Now, I don't have room for that one on my graph. I can state it, because it asks me to state 3 ordered pairs. Now, the bigger the number I put in, it's going to make this one decrease. So I need to maybe if I need to, I would put in a number less than -1 for another point, if you need another point. All right, let's graph what we have, and we'll see if we need another point. -1, -3, 0, -5. Asymptote at -2. Do you need another point? Can you tell what it's doing? Okay, then I'm not even going to worry about that other point. That's going to go way down there. I stated the 3 points, but I didn't have to graph all 3 of them. Okay, range. Which one does it involve? Positive infinity or negative? Negative. So over here, the negative infinity has to go on that side. And what's on the other side? -2. Good. Increasing or decreasing? X-intercept, Y-intercept, 0, -5. And then your end behaviors. As it goes to the right, it goes to negative infinity. As it goes to the left, it goes to the asymptote of -2. All right, I've got 4 problems for you to work.